This is our last lab practice, it's lab number 6. It is about aluminium heat treatments. The objectives of this lab was to carry out the T6 treatments of the 6061 aluminum alloy and its different stages in solid solution, quench and age, during the age hardening process heat treatment. Also, we wanted to analyze the microstructural and hardness changes during these various stages to identify how it's changing a long time. For this lab practice, our materials that we needed were 6 specimens of a 6061 aluminum alloy, also some electric oven as the muffle in order to heat, the Brinell and the beakers hardness equipment in order to make our results, and also the protective equipment for using when we inserted the material to the heat treatments. Those were the only materials that we used for this lab practice.
For this lab practice, what we did was we grabbed a piece of aluminum. We cut six round pieces out of it. 2 of them were left as they were, so we could have a reference. Then we grabbed the other 4 pieces and we put them in the oven. Inside of the oven, the pieces were at 530 degrees for an hour and a half. After that, we took them out and we quenched them in water. After the quenching, we took 2 pieces out and we started doing some tests on them, like Vickers and Rockwell and Brinell. And the other 2 pieces were inserted in the oven again to make a age hardening. They were put into the oven at 175 degrees for approximately 8 hours. It is important to mention that out of the 6 pieces, 3 of them we took them and we left them as they were to do Rockwell and Brinell, and the other 3 pieces we put bakelite on them so we could make the Vickers test, and also see the other 3 pieces we applied bakelite so we could do the Vickers test and to do the metallography.
The precipitation hardening is used for the strength and the hardness of some metal alloys that may be enhanced by the formation of extremely small uniform dispersed particles of a second phase within the original phase matrix. This is accomplished by appropriate heat treatments. This heat treatment is the one that is called precipitation hardening, and it is called precipitation hardening because of the small particles of the new phase that are named precipitate.
Solubilization is when you have to increase the temperature to be able to increase the percentage of the dissolved hardened microconstituents, and that will increase the mechanical properties in a good way because you are dissolving all the microconstituents in the best way possible. Well, the natural aging occurs when you cool to room temperature, and the big difference between this one and the artificial aging is that in the artificial aging you have to increase the temperature to make the process faster and mostly of the times more efficient, and this will also increase the mechanical properties in both cases, just that in the natural you have to cool it in room temperature and it's lower, and then the other one is way faster.
The current precipitate is a precipitate whose crystals and atomic structure is arranged and have a continuous relationship with the matrix from which the precipitate is formed. The temper process is when you take the quenched material and then you put it and heat it again to begin the precipitation of our microconstituents, but not enough to get back into the solution. So this will give toughness to our material. Aging is the process in which we control the condition of our material when we heat it to avoid our material back to the original configuration. Of course, this will create better properties to our material, but if we take a long period and we continue beyond in this process, it will occur the overaging. That is when the hardness, the tensile strength and other properties of our material will decrease. Yeah. The application to artificial aging is only for not cold worked aluminiums. It's only applied to wrought parts. And the 2000 series 600 6000 series, it's only applied in moderated resistance, and 7000 series also applied. And the application of these parts is for planes, forged parts, anodizing parts, windows and stringers, and bodies of planes and automotive parts.
Precipitation hardening is when you have to face it at room temperature, and it can be heated at a temperature that can dissolve the second phase.
Aluminum strengthening mechanisms, we have the first one that is work hardening, that is also named cold working. Then we have solid solution hardening. Then we have fine grind hardening, heat treatments like age hardening, solid treatment, quenching, aging, thermal softening, and annealing. We made a hardness renewal tests in our different materials with no heat treatment, with solubilization, and with the aging at 8 hours. And we got these numbers. We had the first with no heat treatment, we got with this formula with 100.24 hardness renewal. In the second one with the solubilization treatment at 530, we got 157.54 hardness renewal, and in the last one in the age hardening process at 8 hours we got 323.20 hardness renewal. When we did our bigger test, we see that in the no heat treatment piece it shows the lower hardness than in the others of the solubilization and the age hardening at 175 by 8 hours. So with this process we know that the age hardening is really useful to increase the properties of our materials, to increase the hardness than in others. Also, it's very important to take care of the time and the temperature of our process because it will be contraproducent to our piece of metal. Then we did metallography process to our materials, and in the first one with no heat treatment we got an 6 ASTM grain size, and in the second one with when we did only solubilization at 530 degrees we got 7 ASTM, and in the last one with aging hardening process we got an ASTM. So in that we can conclude that if we make an aging hardening process we reduce the grain size. It depends on the time and at the temperature, and we have to design the heat treatment that we are going to do to our materials. So in this case we reduce the grain size so it has better properties than the other ones, and also if we compare it with in the hardness renewal we got really good properties in the third part that we did the solubilization and the aging hardening process.
Thank you.
After doing this lab practice, we could finally see in practice, not theoretically, what we had been learning from the beginning of this course. One of the first of the temas.
Theme.
No.
Topic.
One of the first topics in this semester was age hardening, and for me was one of the most interesting topics because we could see in this how many metals would react to heat treatments, not only like steel would react that we also saw in this semester. So doing this in the lab was very helpful for me to finish understanding what happens when you apply a heat treatment to a metal that is non-ferrous, and also what happens if you cut the treatment in half, like what happened when we just quenched the piece and we didn't apply the age hardening.
For this last lab practice number 6, we could analyze the different stages in which aluminum has its properties regarding in age hardening. It was interesting to know because we could see how it changes actually, how the hardness changes, and it's really important because this is the basics of the whole course. In order, like, heat treatment was the one that we saw the most, and alongside with how it changes through the diagrams, the different hardness, the different composition. So it was interesting to know all of this. And in conclusion, for a general conclusion for all the lab practice, I think that it was really good because we were able to get to know in practice all of the topics that we see in class, because there were a lot, and it's most important in practice because it's almost everything is theory. So making the practice in laboratories was really good, and I really enjoyed it, making most of the lab practice because they were really fun and creative and interesting for us as mechanical engineers.
In conclusion, this practice is really interesting and really important for us as a mechanical engineers, because in this we learn how to do different treatments, heat treatments to our material, in this case aluminium, that it's a really important material in the industry because it's lightweighted and it could replace other material that it's heavy, and what we need in our application is to reduce the weight of our machines, to reduce the energy that it can waste. So this is a really good practice that help us to understand more what is in the industry. And
well, during this practice I was heating for aluminium. I think we learned a lot because we can see how the heat treatments improve the mechanical properties, and we also have been seeing these changes during the whole semester in our project. And well, at the final in this practice we can just conclude that all our results in our project, in our practice, in our last practice, they were like correct because the heat treatments will improve all the properties. Thank you very much.